Hello students, welcome to all of you. In my previous lecture, just you have studied about the arrangement of elements in periods. Alright, and in the continuation of same topic, that is classification of elements, in today's video lecture, we are going to study what are groups and how elements are arranged in groups and what is the main property of these groups. So let's start with the description of groups. So before modular periodic table, that is, I am talking about Mendeleev periodic table. These groups were arranged in vertical columns, although they were arranged in vertical columns, but their scheme of numbering of groups was in Roman letter and in subgroup A and subgroup B. So having there too much anomalies. So for the removal of that anomalies or demerits, in 1984 IUPAC recommended a new scheme for the nomenclature of groups. Listen sincerely. In 1984, the IUPAC means International Union of Pure and Applied Chemistry recommended a new scheme for the nomenclature of groups, and according to new scheme of the IUPAC, groups are numbered as 1, 2, 3, 4, 5, 6 up to 18, means they are arranged in 18 vertical columns. Alright, and these groups starting from left to right, and we have that is first group, second group, and up to 18th group. And up to 18th group is starting from first to 18, and they are arranged in a vertical columns, and the number of vertical columns are 18. Alright, in which the first group, second group, third group, fourth group, fifth group, seventh group, up to 18th group, the arrangement of elements within the group was as usual, means according to modern periodic law, means elements are arranged in the increasing order of atomic number set. Okay, so arrangement of elements within the group was also following the same law, that is, elements are arranged in the increasing order of atomic number. Alright, so what are the properties of these groups? So listen sincerely. The elements which are present in group, or you can say in a particular group, possesses similar type of electronic configuration. The first property of these groups may be explained as the elements which are present in a particular group have a similar type of electronic configuration. Means that the elements which are present in a particular group having same number of valence electrons. This can be explained as, suppose I taking elements of first group, that is hydrogen, lithium, sodium, potassium, rubidium, cesium and francium and so on. So meaning behind this first point is they having same number of electronic configuration or same number of valence electron. So in each each of the element they having this number Same means valence electron of this group, all the elements, not only upper sided, have the same. This is the meaning behind the first point. Means the elements which are present in the group possesses same electronic configuration, means number of valence electron of that element is similar. Suppose we have to represent a francium, and francium atomic number is 87, and that can be, according to Bohr-Bury scheme, written as children 2, 8, 18, 32, 18, 8, 1. Count just 50, 60, 1878 and 78 and 9. 78 plus 9, 87. Am I correct, student? Alright, so 87. So see here, in this, add this, they having all, not only these two or this, all having same number of electrons in valence shell. And if the number of electron is same, then their electronic configuration will be also same, means they possess such type of electronic, means NS1, where N stands for number of electrons present in valence shell. Alright, NS1. If you put N equals to 1, you will get the electronic configuration of hydrogen. If you put N, that is 7. N is 7. You will get the electronic configuration of francium element. Understand children? So this is the meaning of the first point or first property of the group. Second property, listen. When we move down in the groups, listen sincerely, when we move down in the groups, the electron cells increases by 1. Alright, once again I am repeating, these are very crucial, very important for knowing the description of periodic table. So without knowing, you will be not in position. So just listen the lectures clearly and try to understand, then you will be in position to explain neatly the elements which are arranged in this very periodic table. Okay? So second property is, when we move down in the groups, the electronic cells or electron cells increases by 1. What is the meaning of this very point? Suppose I taking elements of 17th group, that is fluorine, chlorine, bromine, iodine and astatine. Am I right? Atomic numbers are 9, 17, 35, 53 and 85. Is it children? Is it? So, according to the property, when we move down the group, the electron cells increases by 1. What is the meaning behind this point? If you write according to Bohr-Bury, its configuration is 2, 7. Means there are 2 cells, number of cells in the fluorine element is 2. But when you move down, that is 2, 8, 7 is a chlorine. So number of cells become 3. So that is the meaning, that increases by 1. Similarly, if you write bromine, that is 2, 8, 18, 7. Number of cells become 4. So 2, 3, 4, that just they are increased by 1. This is the meaning. Similarly, of astatine you can write 2, 8, 18, 32, 18 and 7 maybe. 18, 32, 50 and 8 plus 2, 10, 60 and 60 and 18, 78 and 78 plus 7, 85. Am I right, student? So in this, so suppose this will come 2, 8, 18, 18 and 7. So this is coming 5, this is coming 6 cells. They are representing the number of cells. means 2 cells are here, 3 cells, 4 cells. So just according to property that when we move down the groups, the electronic cells, electron cells increased by 1. So that is 2, then 3, then 4, then 5, then 6. Not only in this, any group from 1 to 18, this property will follow. Just see here. In first group, hydrogen is 1, having only 1 cell. But here, 2 cells. Similarly, here will be 3, 4, and here just coming 7 cells. This is the meaning. Just move down the group. The electronic cells increase by 1. Must remember. Next property of these groups, that is the elements present in group exhibit similar chemical property. Listen sincerely. Third property of the group is the elements present in a group exhibits or possesses similar chemical property. Suppose, what is the meaning of this point? Suppose I am taking the elements of second group. Is it clear? Atomic number is 4, 12, 20, 38, 56 and 88. Am I right? Atomic numbers of the elements which are present in second group, that is this one. So according to the property, the elements present in a group exhibit similar chemical property. Means the elements which are present in this group, means beryllium, magnesium, calcium, strontium, barium and radium, they possess similar chemical property, means they show the property of metals, means all are metals, they are having 2 electrons in their outermost. If you write, all will contain 2 electrons in their outermost, they all belong to same subcell. Means if you write, their outermost electron will occupy S subcell, and so that's why they will be considered as a member of S block. This is the meaning of this very property. Alright. Next property, listen. What is the next property of group? So the elements which belongs to group, listen sincerely, the elements which belong to group first, group second, group 13, group 14, group 15, group 16 and group 17 possesses their outermost cell incomplete while rest inner cells are fully filled. Listen once more. The elements belonging to group first, second, 13, 14, 15, 16 and 17 possesses their outermost cell incomplete while their inner cells are fully filled, called normal element or representative elements or main group elements. They are named as normal or representative, or main groups elements, alright. Suppose I am going to select, suppose I am taking the elements of 13 group, and you are knowing those elements which are present in 30 group, they are, that is boron, aluminium, gallium, indium and thallium. Is it, children? Is it? That is a 13 group. This is boron 5, aluminium 13, gallium 31, indium 49 and thallium 81. Am I right? So according to the property of this very group, the elements which are belonging to group 1, 2 and 13, 14, 15, 16 and 17 having their outermost cell only incomplete and rest inner cells are filled. Means this is 2, 3. So if you write in the reference of S above, that is 1s2, 2s2 and 2p1. Okay, maybe this is. So this, either this or this. Means only outermost cell is incomplete, inner cells will filled. Suppose I writing of gallium 2, 8, 18 and 3 will be 18, 10, 28, 28, 3, 31. Okay. Similarly, 2, 8, 3. So in all the cases, you will see that only outermost cell is incomplete, rest inner cells are fully filled. This is the one of the most important property of these elements. Okay. Next property, the elements belonging to group 3rd, group 4, group 5th, group 6th, group 7th, group 8th, group 9th, group 10th, group 11th and group 12th. The elements belonging to group 3rd to group 12 having their outermost 2 cells incomplete, or you can say outermost cell and penultimate cell of the elements of group 3 to group 3 to group 12 having 2 cells, that is outermost cell and their penultimate cell incomplete. For example, you have suppose we have to write the elements of group 3rd, that is you have heard scandium, that is yttrium, atomic number 21 and 39. Okay, they are in group 3rd. So if you write the configuration, then according to the property, just we are explaining that outermost 2 means last cell and just before penultimate cell means last 2 cells are incomplete, are placed in group 3rd to group 12 of the periodic table, and these are referred as transitional elements. This may be also written as 2, 8, 18, 9, 2. Maybe 18, 20, 28, 30 and 9, 39. I am correct, children? Okay. So in this also, these 2 cells are incomplete. So that property obeying, and these elements are called transitional elements. Must remember, these are called transitional elements. Next property, which number is 5 or 6? The elements which are placed below, that you can say that is lanthanide and actinide series elements. The elements which are placed below in the periodic table in the numbers 14, 14 each, called lanthanides and actinides, having their 3 outer cells incomplete, and these elements are called inner transitional elements. Inner transitional elements. Okay? For example, suppose I am taking one element cerium having atomic number 58, and that is the member of lanthanide family. If you write its electronic configuration according to either above or by Horbury, that will come as 2, 8, 18, 19, 9, 2. Count it. 18 and 10, what? 28, 28 to 30, 30, 19, 49. 49 plus 9, 58. Am I right children? So see here, these three subcells are incomplete. That's why they are called inner transitional. Similarly, you can take one element of actinide, that is thorium. This is cerium of lanthanide. This is a thorium actinide. In the same way, if you write their last three outermost cell will show incomplete and they are termed inner transitional. 28, 18, 32, 19, 9 and 2. This may be counted 32, 18, 50 plus 10, 60, 60 and 19, 79, 79 plus 11, 90. Am I right children? Okay, so this is last three subcells, not subcells, sorry. Last three outermost cells are incomplete. That's why they are known as inner transitional and placed below in the periodic table in the form of lanthanide and actinide series. And lastly children, last property, the elements which are placed in group 18. Listen sincerely. Just before this I have explained almost all the groups. No group is left. All groups I have explained properly. And last property, the elements which are present in 18th group of the periodic table possesses there all the cells fully filled. Means there is no any cell incomplete. Alright? The elements which are present in 18th group of the periodic table possesses all their cells fully filled or completely filled. Okay? And these are called inert or noble gases or inert or noble elements, and you all are knowing these elements very neatly. These elements are, that is helium is the first element, helium, neon, argon, krypton, xenon, radon and ignition. OG, just I have explained yesterday. So this is atomic number 2, 10, 18, 36, 54, 86 and perhaps 118 of ignition OG. OG is the last element which is discovered very soon, and its symbol is OG and name is ignition, having atomic number 118. This is the last element of our periodic table. So if you write according to the property, there all the cells will be fully filled. That is 2, 8. Similarly 2, 8 and 8. Similarly of 2, 8, 18, 32, 18 and 8. Is it 32, 50, 60, 60 and 78 and 8, 86. Similarly this will be 2, 8, 18, 32, 32, 18 and 8. Okay children, 50 and 82, 82 and 18, that is 100 and 10 and 18. Correct children? So in all the cases, similarly you can write up them also. In all the cases, all the cells are fully filled. That's why they are called the member of 18th group, and they are chemically inert and they possess same kind of property, same kind of configuration. That's why they are also termed noble. So this is the description of those. Must remember it. And in next lecture we will study, that is how the elements which having atomic number more than 100, how they are nomenclated. Listen once more. The elements which having atomic number more than 100, how they are nomenclated. That is in your syllabus. I will discuss in upcoming lecture. So till prepare it. Thank you for joining us. Have a nice day. Be sensitive.